Hey everyone, welcome to my YouTube channel. Today I'm going to be talking about building a contextual assistant using the Rasa framework. It's one of the biggest machine learning developer toolkits for building AI-driven chatbots. The chatbot in this presentation is a real-time weather reporting bot. It uses a service called WeatherStack to report weather conditions. So during the conversation I will have with it, it will use machine learning to predict my intents and take actions on those based on what it's learned in order to progress the conversation. So this is an outline for today's talk. I'll talk a little bit about AI in general and the evolution, where we are today, where we were, and where we're going for the future. I'll briefly touch on some things about the Rasa framework. We'll look at what that exactly is. And then we'll have a high-level overview of the stack. We'll look at basically what happens when input comes into the stack, how it gets parsed, and the actions that it takes. We'll also look at one of the components, one of the main components to Rasa, which is the natural language understanding component. There's a neat little algorithm that takes play behind the scenes, and that's called Bag of Words. So we'll do a little talk about that, and then we'll discuss some pipelines, what's supported with Rasa. I'll also talk about Rasa Core, which is the second component, and then we'll wrap it up with a demo. So, artificial intelligence, the evolution. But before I get into that, I just wanted to talk about contextual conversation. So, what exactly is that? It's basically a conversation that's had where the previous context was recalled beforehand. Uh, so, with that being said, let's just look at this AI assistant timeline. So, what we currently have is, or what we had before in the past is notification assistance, and these are just simple SMS notifications, notifications you get in app, such as like WhatsApp. It may send you notifications through your iPhone or your Android phone. So that's notification assistance. FAQ chatbots are just a little bit better. They're wrapped around what's called a state machine. So basically, a state machine is certain paths that you can take that are tied around a set of rules. But the problem with that is there's no previous history of the conversation. So if the conversation diverges just a bit from the original path, then some of that context is completely lost and it's prone to mistakes. So where we are now, we are at contextual AI. So contextual assistants, they consider the context of what was said before and gracefully handle and drive the conversation if it diverges from a conversation path. And after that, really, it's just where all this is headed from here on out. So it's like you can have personalized assistants, and basically these are assistants that are personalized to fit your behavior patterns. So it's personalized to you. It makes recommendation based on preferences that it's learned about you over time. There's also autonomous organizations, and that's really just a paradigm in which like an entire company, the operations are driven through artificial intelligent assistants. So basically, assistants will know about each customer personally. So these assistants will be able to branch off and take care of a lot of segmented parts of that company. So before I touch on some facts about the Rasa framework, I wanted to also mention that this framework was started off as a project on GitHub in 2016. As of today, there's over 7,000 plus active members on their forums, so there's a huge community of supporters. It's AI focused on bot building, essentially a bot building toolkit. The nice thing about this is you can develop a bot locally or deploy it in the cloud, totally your preference. It does come with a pricing model, so you're free to use the open source library, but if you decide to use the enterprise edition for your enterprise solution, then that will cost money. And basically, that just provides a couple more features than what's provided already through the open source library. And those are like single sign-on, role-based access, analytics, etc. Yeah, so basically, this framework automates text, voice-based conversations. It's an open source machine learning framework, uses Python under the hood and a multitude of libraries. Yeah, so the two main components are the Rasa NLU. This is actually really the main component. And it's a set of tools to help you build a language parser, which uses NLP and machine learning libraries. And there's also Rasa Core, which is the dialogue management aspect of it. Basically, what it does is it predicts what actions to take based on an abstracted representation of your training data. So it learns from like previous conversations that you have and then takes actions based on that. It's easy to integrate. So you can integrate it with Facebook Messenger, you can integrate it with Slack. It also comes with Rasa tools, Rasa X. And that's just a set of tools to help you build, deploy, and improve the chatbot. So it's just a nice little feature that gives you interfaces to play with that make your daily interactions with the bot much more pleasurable. So this is the high-level overview of the stack, interaction, and things like that. So I'll kind of walk everybody through this. So again, Rasa is really two pieces, Rasa NLU, Rasa Core. So in this diagram here, so if the user says, what's the weather like in San Francisco, Rasa NLU takes the input and converts it to something useful. And really what it's doing is it just converts it to a JSON file. And inside of that, it just classifies intents and entities. And what an intent is basically it's a list of intents from your training data, and entities are just real world objects. Excuse me, can't talk. So this conversation, or I'm sorry, this input text, which is what's the weather like in San Francisco, goes through the NLU parser. The NLU determines or predicts that the intent is action weather with a 93% probability. And the entities that it's also extracted are San Francisco, and it places that in a slot. I'll go over what that is in the next slides. But essentially, just what a slot is a piece of it's a place in memory that you can store certain data types in. So really, Rasa Core does something conceptually different. It may use previous trained data to run actions, and actions may run simple database queries or integrate with your CRM to pull customer-related data or make an API call, which in this case, it's going to make an API call to the WeatherStack API and return some data. Oops, where did I go? There we go. Okay, so yeah, Rasa Core determined that based on previous train data that the next action was action weather. It makes the API call, returns some data, and then you get weather conditions. So that's what it is, high level. Go to the next slide. So yeah, so really Rasa NLU, just to sum up things, takes a string, classifies it against a list of intents. So the two classification properties that NLU has is intents. So intent can be like agreed intent, a confirm intent, it can be a custom action. Entities are the structured data, so you can think of these as real world objects. So they can be like emails, they can be dates, products, names. I mean, it could be whatever. There's a couple of guidelines with the training NLU model. So it needs to be trained on an initial set of data. The examples should be diverse and different. A good rule of thumb is more than 3 examples per intent. And these examples are kept in a JSON file and can be directly written to, or you can use the Rasa X interactive mode, and you'll have a nice little interface where you can predefine your intents, entities, and whatnot. So bag of words algorithm. So really, a bag of words algorithm handles the data mining part, and the bag of words algorithm is based on the Euclidean distance formula, and it's for finding occurrences between documents. Really, what a document is, a document could be a word, it could be a sentence, a paragraph, a PDF file, it could be any corpus of text. So this algorithm provides a way to represent data for machine learning. So how it does that is it creates word vectors, and word vectors are used to train a classifier. And in this case, a classifier can be a linear regression or a neural network. Classifier I used was a neural network, and basically what it does is if you send this input text into it, did it again. It gets classified under the neural network, which predicts which intent that it should belong to. So out of these 4 intents, you have greet, goodbye, confirm. It's predicted that you're asking for you want to know the weather, so it wants to ask what the location is. All right, this slide is just a continuation of the last slide, and this is just like kind of a view from the top of what's going on. So it's like input in, output, and this is exactly what the NLU part produces. So it takes like this string input, and then it basically structures this in a JSON file. So I'll go through what this means. So the incoming text is, I'm planning a vacation to San Francisco. I wonder what the weather is there. So the NLU has classified this as an intent, and the name is inform. It also extracted some entities based on previous training data, and the training data here is San Francisco, and it's classified that as an entity location. And it also gives you an intent ranking here of what it thinks other intents it could classify against. So pipelines. So really, a pipeline in Rasa is a set of configs, and you use that to process your incoming messages. So choosing an NLU pipeline allows you to customize your model and fine-tune your data set, really. So I used an out-of-the-box pipeline called sklearn, which is based on Spacey, and I just did that for simplicity. So there's 2 types of pipelines. There's pre-trained embeddings, and that's again by Spacey. It's a language model that comes with pre-trained word embeddings. So good word embeddings aren't available in all languages, and languages can be difficult to convert. So this actually language model only has a handful of languages that it supports, amongst one of those being English. So if it's a language that is not part of this model, then it would not be useful in that case. It's not great for out-of-domain words. So things like slang or typos, this language model would not be good for that. And there's also supervised embeddings. So supervised embeddings, it basically learns everything from scratch. There's no pre-learned knowledge from language libraries. The model's learned from your own language, so it's language agnostic. And advanced cases are messages with multiple intents. So like balance versus cache, and in one domain, balance can mean something that involves symmetry, and cache can mean something that involves currency. In order to classify this as a domain specific thing, it'd be probably better to use supervised embeddings. The only drawback with supervised embeddings is that you don't have pre-trained knowledge, so you have to kind of either start, having conversations with the bot, or throw it in an environment where it starts to learn from domain-specific things, or train it on a domain-specific corpus of text. So of course, all those comes with a lot of time constraints, and training a model and to a specific set of intents can take some time. So before I get into Rasa core, I just wanted to say that Rasa stories, which is this JSON file here to the right, it is a form of training data, and it's used to train dialogue management models. So basically, this is a story. This is a conversation I had with the bot, and it generates this thing that's called a story, and basically it classifies a lot of the actions that Rasa core will take. For example, this is an action. It's called utter greet. I did it again. Sorry about that. Oh, there he goes again. I won't touch the mouse again. I promise. Where was I? Okay, so this is a generated story. This is an utter greet action. So there's two types of actions. There's utterance actions, and these are just text-based responses based on learnings of the model. And then there's custom actions. So a custom action is action weather here. This is one of my custom actions. So what it's doing is it predicted an form intent. It's placed a property in the location key. It's put that in the bot's memory, which is a slot, and it's running action weather here. So these are all tied around events. So Rasa core supports event handling. Rasa core also has policies. So what policies do is they help you to predict what the next action is. And the policy that I'm using for this assistant is called Keras policy. It's based on LSTM, which is a neural network. And Keras policy really just runs on top of TensorFlow. And you can write your own custom policies if you wish. So that's a cool thing about that. And you a little bit about slots. So basically, a slot is used as bot's memory, and it can be used to store information extracted from the conversation. So these are stored with a key value store. So as you can see here, that's a slot. It's holding some information in this key. And it supports different data types. So it could support categorical, bool, float, and list. Okay, let's go ahead and then do a demo. So this is the Rasa framework and code base for the bot that I had created. So let's see. I'll just go over the NLU model here. And basically, it's a Python script that helps you train your NLU data. And and you can invoke this, and it'll actively train your data JSON. So your data JSON is basically some common examples that you add, and it's an initial training set of data that you would use to train your bot. And basically, oh, there we go. Basically, what this does is when you train the NLU model, it uses that initial training set. It uses the configs that you use, and the configs that I'm using is right here. So this is my pipeline. I'm using spaCy sklearn, and it's also using the initial data set that I have specified the path here too. So once this is run, it'll essentially load the training data set. It'll pass those configs to the NLU training module, and then pass the training data to the training pipeline, and then you'll have a trained model ready to go. So yeah. So let's look at the actions. Okay, so I created this custom action here to fetch weather conditions based on a location that you provide. So essentially, what this does is it hits the weather stack API, and so I've got an API key here, and then I've got some parameters that I set here. So the first thing that it does once this gets invoked through an event, it'll go into a slot and grab a location, and it'll set that location variable. So I have the request library here that will make a GET request with the parameters that I've specified in the URL. I will set a few variables here. I will create a response variable, and then I'll go ahead and dispatch that message back to the user. So that's pretty much the bulk of what the custom action will look like. And then let's see. And then for Rasa core, so this is the stories markdown file, and basically every conversation that I have with the bot will be placed in this file. So and this file will be used to use as a set of training data. So the Rasa core will be able to predict, based on previous conversations that I've had, what the next action is that it should take. So I will go ahead and demonstrate interacting with the bot here. And so I've integrated my bot with Slack. So looks like I've already had a conversation here. So I've greeted the bot. I said hi there. The bot has responded with, "What can I assist you with?" So I'll just type some text here. I would like to know the weather. Okay. And oh, I forgot to tag them. All right, let me go back. There we go. All right, great. So it's based on what I've based on our conversation. It's given me the temperature for San Francisco right now, so that's 50 degrees. The humidity is 74%, and the wind speed is 121. So I'm gonna go ahead and thank the bot. Thanks. That's great. Okay, so maybe it just didn't understand that, and I hadn't trained it initially on that specific response. So I'll just say thanks. All right, now let's try something else. Let's ask it one more question. I have one more question. Okay, so I'll just say I wanted to know the weather in Livermore. Oh, I didn't tag it again. God. You can tell I rehearsed this so many times. There we go. Great. So it says it is currently clear in Livermore at the moment. The temperature is 48 degrees. The humidity is 74, and the wind speed is 6. All right. Well, thank you. Okay. So I'll also quickly show you what the Rasa CLI tool is like. So you invoke it with just Rasa, and these are the commands that you can run. So you can start a Rasa server with your trained model. You can run a shell. You can train your model, and you can run it in interactive mode. So what's cool is this tool set gives you this visualize mode, which is basically it gives you a visual in graph form of the stories that you've had or conversations that you've had with the bot. So go ahead and run that. Yeah, so you kind of have this kind of graph view and a start state and basically every iteration of the conversation. And if you find that there's some path here that the bot took that maybe is not right, what's nice is you can go into interactive mode. And basically what interactive mode does is it helps you train your bot and it learns. It'll ask you a series of questions and you'll kind of go back and forth with it. So I'll go ahead and demonstrate that here. Looks like it's still taking its time to do something. Oh, I'm already using that port. I know exactly what's going on. Okay, so I'll have to stop this server. Oh, where's my mouse? So let's stop this. I guess I could just run it from here as well. So I'll just do Rasa interactive. Okay, so what you should see is a terminal with asking you to type a message. So I'll put hi there. So it says that my NLU model classified as hi there with intent greet, and there are no entities, so that's correct. So it classified it as intent greet. So the initial state was the bot was performing action listen, which was just waiting for input. Second state is me typing input, saying hi there, and it classifying that as intent greet. So the next question is the bot wants to run utter greet. So it wants to greet me back, so that is correct. And I'll just keep typing either a yes or no to go through these interactions. So the next action is, so it performed utter greet, and it sent me back a message saying, greetings, what may I help you with? And it wants to perform action listen, so I can type some input, and that's correct. And I will say I want to know the weather, and it predicted that It predicted an inform intent with no entities. That is also correct. So now it's saying that the bot wants to ask me the location. So that is also correct. So I will say run action listen again so I can retrieve input from me. Now I say in San Francisco. And it's also classified this as an entity, so it's going to go ahead and put a slot location of San Francisco, and that's also correct. So on and so forth, and you kind of take this pattern and train the bot interactively. So that was all I had for this presentation. I hope you enjoyed learning about Rasa framework as much as I did. I'll go ahead and leave a link to the GitHub repo on this YouTube video, and tell me what you think.